Today I'm going to teach you how to use page 5 in your Earth Science reference tables. This page is all about tectonic plates, and we've learned a little bit about tectonic plates. We've learned about the East African Rift and how it is splitting apart over there, and you've learned a lot about the different boundaries that are present all over the world and how they cause earthquakes and volcanoes. And so on this diagram, this is kind of a complicated diagram. We're going to kind of break this down a little bit and show you how to use this. For example, if you live in Ghana, which is right over here, you are living on the African plate. If you live on the island of Dominican Republic, you live right about there and you are on the Caribbean plate. Same thing for Puerto Rico. Puerto Rico is right there. You are also on the Caribbean plate. If you live in Guyana, that is right about there. You live on the South American plate. So there are all these different locations in the world, and you might be living right exactly on top of a plate. But there are also interesting things that are happening in the world at the plate boundaries. So let me kind of erase some of this here. And the key at the bottom of this diagram, or on the bottom of this page, shows you a lot of different things that are going on this map. So for example, right here at the bottom, it tells you that an arrow is showing you the relative motion at a plate boundary. So for example, I could zoom in right here where there are two arrows moving away from one another. And so this is telling me, this arrow here is telling me the direction that the Antarctic plate is moving at that boundary. And you guys know your north, south, east, west, or your never eat soggy waffles. Or I always remember that the E points east. That always helps me because I messed that up. Or I remember that this spells wee instead of, because I know a lot of people mess this up, instead of ew. That one's wrong. Ew. Wee. That one's correct. That's how I always remember that. Anyway, so once you have figured out we call those your cardinal directions, then you can figure out what direction that this Antarctic plate is moving. And it is moving in that direction, which on my thing is southeast. So the Antarctic plate is moving southeast. And this arrow is showing me what direction. What plate is this? Oh, it's a great big plate. This whole entire thing is the Pacific plate. And if we look at these directions, that arrow is moving in this direction. So that tells me that the Pacific plate at that point, at that location, is moving northwest. Okay. So, having some technical difficulties here. I'm going to start that again. There we go. So once we have our little directions, we know the relative plate motion at the different plate boundaries. We can also look at the different plate boundaries that are located down here. So we've got the first one is transform plate boundary. You guys learned about that. That is represented by a solid thin line, and you can see that the plates are just kind of moving past one another, side by side. We also have a divergent plate boundary. That's our second one, and you can see that they're moving away from one another, and it's indicated by this double line. And we have convergent plate boundaries. That's our third type, which you can see is a solid line with these little rectangles on one side of it. Those little rectangles tell you which one is the overriding plate. That's the one that goes over top. And the one that doesn't have those little rectangles is what we call the subducting plate. It's the word sub, or that root word sub, means under. So that is the plate that's going underneath the other one. And you know this. Submarine is underwater. So that means that subducting plate is the one that's going underneath the other one. This overriding plate is going over top of the subducting plate. So those are our three types of plate boundaries that we know about. And then a dashed line shows you that there's something going on. There's a plate boundary there, but we're not really sure what kind of plate boundary is located at that place. And then finally, we have these things called mantle hotspots. These are places that are really, really hot, and it's quite possible that it's going to start some convection there, or maybe it did at one time in the past, but there's no convection happening there right now. But it's hot enough that there's usually volcanoes that are erupting in those locations. And there are lots of hotspots all over the place. In fact, this one up here is the Iceland hotspot that was just erupting a few years ago and caused a lot of problems for planes that were trying to land in that area. So hotspots are kind of a cool thing. All right, so that's what's going on at the bottom here with the key and the different locations that you have these different plate boundaries. And you can see some of them on this map. The last thing that I want to show you is latitude and longitude. So for example, if I wanted to know, for example, I'm going to get rid of some of this stuff, where some of these locations are, for example, the DR or Puerto Rico, I would use latitude and longitude coordinates to figure that out. So I'm going to zoom in here on the DR and Puerto Rico. And I know I've also included Haiti there, but you get the idea. They are located on the Caribbean plate. And if we wanted to be able to distinguish where these two are located, we would use latitude and longitude coordinates. Your phone, whenever you look at your phone and there's that little blue dot that says, ooh, that's where I'm at, your phone is using latitude and longitude coordinates. That's how it tells you. That's how GPS works. And if you, as you grow up, if you want to get involved and you want to have a job that involves location and technology, maybe video games, a lot of those things that need to use programmers to be able to use latitude and longitude to figure out where those places are located. Okay, so latitude and longitude is actually a pretty important thing in our world and for you to understand it. So for example, if I wanted to tell you where Puerto Rico is located on a map, I'd use lat long, and hopefully you guys already know that latitude lines run horizontally across a map. So this is a latitude line. I'm giving you a very brief summary here, a really quick rundown, a summary of lat long. And so if this line is at 20 degrees, and you can see it's 20 degrees on both sides, I know that that is north. Now I know you might be thinking to yourself, wait, miss, this is on the east side of the map. I know my directions. We just did this. Never eat soggy waffles, right? That's on the east side of the map. Why isn't that 20 degrees east? Wrong. Because then why isn't it 20 degrees west over here? It's the same line. It can't be 20 degrees east on one side and 20 degrees west on the other side. It's the same line. So it's got to be one cardinal direction. The reason it's north and not east and not west is because it's being compared to this line right here. This is the 0 degree latitude line, which is called the equator. And this latitude line, 20 degrees, is north of the equator. And so that's why we call that line a 20-degree latitude line. Okay? All right. If you didn't catch that, click rewind and rewatch again. Make sure you understand it. That is super duper important. Okay. So now that we've got our latitude lines, let's take a look at longitude. So if I'm in Puerto Rico, I'm going to zoom in again. Where was it? Here it is. Puerto Rico, right there. Longitude lines run vertically. This is a longitude line. Okay. So this is 60, here's 80, that halfway is about 70, so maybe 67, we'll say 67 degrees, okay? And if that's 67 up there, that means it's also 67 down here. So this line can't be a north-south line. It's running north-south, but it's measuring east or west of another line. And then the other line is called the prime meridian. Maybe you've heard of it. Hopefully you've heard of it. This line right here is the 0 line. It's the same kind of thing as the equator. It's like the longitude equivalent. I'm not spelling that right. Let's try that again. Here we go. It's called the prime meridian. So the prime meridian is kind of like the equator of longitude. And since that 67 degrees is west of the prime meridian, that means that it's 67 degrees west. On to the right of the prime meridian, those are called east. Now I know you might be thinking to yourself, wait, miss, there's only a few east. That doesn't make any sense. Why are there only a few easts? Well, remember, the Earth is a globe, and we have a flat map. So I zoom myself in here. If you're looking at a flat map like this, and you only have east that goes up to here, remember, the easts are going to curve around and they're going to continue onto the other part of the map. So even though east stops here, it keeps on going over here until you get to the halfway point. Well, what's the halfway point? Remember, Earth is a globe, 360 degrees all the way around. So halfway around is going to be 180. So if we take a look at our map and we go east, these are still east until we get to 180. And then all of these are going to be east longitude lines. And then these are going to be west until you get to that 180. Okay. This is a weird map this way, and the reason it's set up is because they wanted to have the entire Pacific plate in the middle of the map and not offset, so they had to shift everything to the right. That's why it's set up this way. So hopefully that makes sense. Hopefully this helps you, and good luck.